going to start delving into some coding today. Well, I take that back. We're doing pointers. And then OOP. So we're going to start actually getting to this course. But hopefully after this, we'll start getting to actual data structures as well. So it's coming up. I know there's been a lot of, I guess, pre-work for this course, but that's just how it's set up. So we're going to talk about testing, pointers and OOP. How many people like testing the code? You do?
Oh, yeah.
Every day?
Every day.
Every day. Just sit there.
1 plus 1.
You like testing?
It's frustrating.
It's frustrating. Yeah, testing's general. I haven't found too many programmers that enjoy it, but it's actually incredibly viable and necessary, and will be helpful. If you do testing, you will be more productive. We're also going to talk about pointers, which you think are easy, but turn out to really get to you very quickly because of the power they provide. And then we're going to go into OOP for C++. OOP in C++ has a lot of similarities to Java, but it has some very significant differences that you must keep in mind. All right. So testing. And all right. Overview. I just talked about all this. Testing. All right. I have underlined this, bolded, and italicized it. I don't know what else I can do to help you with this, but testing will make you more productive. Please test your code. When you come and talk to me about why your data structure is not working or you're not passing a lab, I'm going to ask for your test cases. Please show me you've tested, and I'll help you derive how you should be thinking about testing your code in order to fix the problems. This course is really, we're trying to jump you from going online, finding code, copy pasting it, and changing it to actually producing and creating your own programs. So it's going to be a little different. You need to learn how to test your code. You need to learn how to come up with test cases and move forward. All right. What I mean by you'll be more productive, you'll spend less time working on your problems if you test your code, and you'll increase your chances of getting it right the first time, and you'll virtually eliminate making the same mistake twice, because you'll be putting your test cases in a test bake, essentially, or what's called a regression test suite, and then you'll run your code, so when you accidentally make a mistake, it'll instantly tell you that, and so that you can fix it immediately. So one proven fact is a computer cannot sufficiently generate test cases for your code. Why do I mean proven? Well, I mean this guy named Turing, this is back in the 1930s, wrote a proof that shows beyond a shadow of doubt that it's impossible for a computer to determine if another program halts. That is impossible. A program cannot determine if another program halts. You take analysis of algorithms, or you want to go Google this, it's called the halting problem. It's very important, but basically, we cannot determine if another program halts. That is impossible. We have actually proven that it's impossible. So if we don't know how it halts, how can we test? Is really what the question comes down to. Is my version of this proof. It's your job to do testing. It's really an advantage you have over computers, and it's why I think programmers are going to pretty much be in existence for a long time. Computer's not going to be able to automatically write code for you because it can't even test it correctly and doesn't even know necessarily the requirements, while us as humans can actually go in and write test cases and come up and generate these things. Do you understand what I'm trying to get at here? Yeah, I know this is really, really annoying, doing test cases, but you have to understand that it's very, very important. It's something that also just cannot be automated. There is a lot of different testing. There's actually a whole class I teach on testing for your master's program. It's actually very useful and not as bad as you think. It's actually a good course overall. But it is, yeah. At first, like, Morning. For this class, we are going to be doing unit testing. There are tons of other testing. This one, unit testing. Because what we're writing is basic units of code. Believe it or not, it's still just basic units. There are numerous unit testing tools for C++, but there's no de facto for C++. In Java, hopefully I at least exposed you a little to JUnit, so you at least have an idea of what I mean by unit testing. In Java, JUnit is essentially the de facto standard. It's what everyone uses to do unit testing. I've chosen to use CSX TestGen for this class. I think it's the simplest one that still is very robust and will meet all of our needs. All right, so how does this work? First off, you need to make sure you have CSX TestGen installed. So there's the command. Notice when it starts with a pound, or do y'all prefer hashtag?
Sharp.
Sharp? You want a sharp?
No.
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 All right, so pound, apt install CSX TestGen. It probably has, are you sure? Yes, and then go from there. All right, how do we do a simple test case? All right, I haven't talked about classes, but I wanted to make sure we had some code in here. You have to include the test suite. Limits and STDIO is just helpful for now. You need to have your code you want to test. I haven't talked about classes. Public class inherits from public CSS test in test suite. Just copy paste that for now, trust me. Public, and then you have your test cases. Usually it's one function per test case, so test one here. Well, just to make sure that if you try and add 1 plus 2, you do indeed get 3. Let's go ahead and see this in action. We'll go inside of testing. And if I recall correctly, I have given you a default empty test. We'll put it right here. And an empty test, that's your template to start from. We'll go ahead and, excuse me, void sum int a, comma int b, return a plus b, and then over here we might have that's our ts assert sum of 1 comma 2 is equal to 3 semicolon. All right, so now that we have that, we have to actually, the way this works is you have to generate the test runner with this code, CSS TestGen, runner, error printer, then output the CPP file. So notice that this is actually, is it 2 dashes or 1? No. Actually, it's generating a test runner. And do we need to specify that as well? Yes, we do.
Spelled runner wrong.
Oh, I did. If I do an ls, it generates, whoops. Let's make that the CPP file, and let's delete that old one. Ooh, that was bad. Clear ls. All right, testrunner.cpp. If you were to open this up, it's going to say a lot of stuff that doesn't make any sense. You don't need to understand what this is doing, because that's part of the test program. It generates a CPP file to do the testing. So now you have that. You have G++, the test runner. No such file or directory. Hey, I know why that is. Because I put error print and I meant to put error printer. Boom. Return statement with a value. Ooh, looks like my code is wrong. How about int? Come on, guys. Should have cut that one on me. Regenerate the program. Whoops. Recompile. Hey, look, we're good to go. And then if we run the program, notice I did not write a main. The test suite is going to have its own main. All right, running test 1, okay. All right, that seems like a lot of typing, and we probably don't want to type over and over again. What should we do? Okay. Good. Excellent. All right. So I'll do makefile. We'll have a test rule. We'll do G++. Let's see what we got. Test-runner.cpp and then test-runner. Make, compile, and go. Ooh, test runner command not found. Oh, a.out. Show test-runner. So it'll actually output our compiled code to test runner. Then we'll type in make. There. Now when we're back inside of testrunner.cpp, if we want, whoops, not CPP, if we go back to our empty test, which was a terrible name, I should have renamed it, we can have test 2. Maybe we'll make sure the sum of 5 to 8, or 5 and 8 is 13.
And let's go ahead and write a bad test just to show you what happens when it fails. 527. So that's a bad test, so we're not running a good test. Make test, expected. So there was a coding error. Oops, I should have looked at the error first. On line 24, expected declaration before curly bracket. All right, 24. Ah, yes, because we only want one of these because it's inside of a class. So, assertion failed, sum of 5 to 7 equal 13. It said that that should have been true. Failed 1, skipped 0, success rate 66%. And it actually gives you some feedback and tells you exactly which test you failed on.
We good so far?
Keep in mind that if we want to test code in other files, we simply include that file number 2. For example, if we had a sum.cpp, the number 2 would just be sum.cpp test.runner-o to test-runner, and then we'd be done. Naturally, you can add optimization and profiling if desired. This runs separate of it, so it's not going to mess up optimizations or profiling if you want to, although I don't know why you would want to profile this at this point. Again, we didn't talk about profiling. And these are 2 extra slides that I forgot to delete. All right.